Hey everyone, now that I've learned all the techniques available, it's time for us to look at a combination of techniques. So what do you mean by a combination of techniques? Let's look at the first example. Let's say we have 1 plus e power x holding power half. Alright, so as you can see, right, it's a exponential in a binomial expansion. So let's say if the question wants us to get to Mclaurin expansion of until the cubic power, we just need to actually follow the formula inside. So for binomial expansion, you have to basically get the form of 1 plus fx. So the common idea is, because you make the common into 1, it's advisable to actually expand inside first. So for exponential, the expansion is basically 1 plus x squared over 2 factorial, then plus x cubed over 3 factorial, and so on and so forth. So let's expand inside first. So inside you'll get 2 plus x squared over 2 plus x cubed over 6, and the whole thing power half, or simply root. Then you can add the plus dot dot outside. That works as well. Thereafter, you just do the same thing, right? Because now you have a 1 plus fx. So now you just perform your binomial expansion. Before that, the same thing applies. Get the constant to 1, it means you have to factorize out 2 to the power of half to become root 2. Inside the brackets would be whole thing divided by 2. So I get 1 plus x over 2 plus x squared over 4 plus x cubed over 24. You can add the dot dot inside or dot dot outside. I'll just show you both variations in the left and right. Okay. Now I just perform the expansion root 2. Now following the formula, right? 1 plus fx is basically 1 plus nx plus n minus 1 to factorial x squared, and so on and so forth. So we just follow this. So we get 1 plus half x over 2, so half, then you have fx, right? X squared over 4, x cubed over 24. Now next one, half minus half over 2 fx squared, so x over 2 plus squared over 4. Since we're only interested up to the cubic level, cubic power, we need not include the x over 24 here, because this whole thing is now fx squared. So we can simply add dot 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 square. The last one, because we still need a cubic terms, this will be basically applying the same logic, is half minus 3 over 2 over 3 factorial, which is 6 fx cubed. So the only term I'm interested in is basically x over 2 cubed. Now I add a dot 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 outside. What I like to do first is simplify the brackets inside first, so lesser chance of a careless mistake as well. So I get 1 plus x over 4 plus x squared over 8 plus x cubed over 48. Okay, plus, now on the right side is actually minus, so minus 1 over 8 x squared over 4, because it's now the square, right? X over 2 squared is x squared over 4 plus x cubed over 4. Alright, because x over 2 plus x squared over 4, you square it, you get x cubed over 4. So it's still 2ab again. Last one, plus. So here is 2 minus sign, so it becomes plus, right? So this would become 1 over 16, then x cubed over 8 plus dot dot dot. Now we can apply the factor now, or you can simplify this first. So you can group all the terms together. So I group the x term together. Now I look at the x squared term. So I get x squared over 8 minus x squared over 32 to give me 3 x squared over 32 plus x cubed over 48 plus x cubed over 128. So from here, 48 times, well, something would. So this is basically 16 times 3. Okay, I'm not going to really solve this for you guys. Well, I mean, it's basically going to be like 3 times 11 over 128 times 3, which I think is 384 x cubed plus dot dot dot. I think so. Alright. Hopefully I'm right. Whatever, you guys can do this yourself, alright? So basically now you just simplify this, you get 3 root 2 x squared over 32 plus 11 root 2 over 384 x cubed plus dot dot dot. All right, so this is basically the general idea of combinations in Mclaurin series. All right, first thing first, always expand the inside first. So whether is it the bracket, whether is it in the power, whether is it in the trigonometry degree, or the radians of the trigonometry. All right, so there we have it, the Mclaurin series of combination.